Welcome to Math, where problems are no problem. Sine, cosine, and tangent, three words that show up in every trig class, and they trip people up because they sound like some secret code. But by the end of this video, you'll see they're just three simple ratios hiding inside every right triangle. Here's what you need to know first. We're only talking about right triangles. Triangles with one 90-degree angle. Every right triangle has a hypotenuse, which is the longest side, opposite the right angle. Then, for any other angle we pick inside that triangle, the two remaining sides get names too. The side directly across from our angle is called the opposite side, and the side touching our angle, that isn't the hypotenuse, is called the adjacent side. Once we label those three sides, opposite, adjacent, and hypotenuse, sine, cosine, and tangent are just three different ways of dividing them. Sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. Tangent is opposite divided by adjacent. There's a classic memory trick for this. SOH-CAH-TOA. Sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse. Tangent, opposite, adjacent. Let's make this concrete. With one triangle, we'll use the whole way through. Picture a right triangle where one leg is 3 units long, the other leg is 4 units long, and the hypotenuse is 5 units long. This is the famous 3-4-5 triangle. Let's pick the angle theta sitting at the corner where the side of length 4 and the side of length 5 meet. So from theta's point of view, the side of length 3 is directly across from it. That's our opposite side. The side of length 4 is touching theta and is not the hypotenuse. That's our adjacent side. And the side of length 5, opposite the right angle, is our hypotenuse. Now let's find sine of theta. Sine is opposite over hypotenuse, so that's 3 divided by 5, which equals 0.6. Next, cosine of theta. Cosine is adjacent over hypotenuse, so that's 4 divided by 5, which equals 0.8. And finally, tangent of theta. Tangent is opposite over adjacent, so that's 3 divided by 4, which equals 0.75. Notice something neat here. Tangent is actually just sine divided by cosine. Watch, 0.6 divided by 0.8 equals 0.75. Same answer we got directly. That's not a coincidence. It's true for every angle, every triangle, always. Tangent equals sin divided by cosine. Now let's verify all of this actually holds up using the Pythagorean identity, which says sine squared of theta plus cosine squared of theta always equals 1, for any angle. Let's test our numbers. 0.6 squared is 0.36. 0.8 squared is 0.64. Add them together. 0.36 plus 0.64 equals 1. It checks out perfectly. We can double-check this a totally different way too, using the original side lengths before we divided anything. The Pythagorean theorem says 3 squared plus 4 squared should equal 5 squared. 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. 5 squared is also 25. They match, which confirms our triangle was legitimate in the first place. And that's exactly why sine squared plus cosine squared always lands on 1. It's the Pythagorean theorem in disguise, just with every side divided by the hypotenuse. So here's the one big idea to carry with you. Sine, cosine, and tangent are nothing more than ratios of a right triangle's sides, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And once you know 2 of them, the third one, and even the whole shape of the triangle, falls right out. If this helped, the next video covers finding missing sides and angles using inverse sine, cosine, and tangent. If you're finding these videos useful, subscribing helps more of them reach people who need this too.